For a lot of Algebra 2 students, logarithms are a very new kind of function. The definition of a logarithm is that it's the inverse of an exponential. So if we started off with b to the p power is equal to L, then the log base b of L is equal to p. So that gets a little confusing, but to kind of decipher it a little bit, notice that the base of the exponent and the base of the log, they're both b. So both of these are referenced in terms of their base. Also notice that what was the power is now the value of the logarithm. So the value of a logarithm is a power of an exponential. A common question, whether it's your Algebra 2 class or the ACT or the SAT or whatever, is to rewrite a logarithm in exponential form. So we'll go through a lot of examples of that. In order to convert between a logarithm and an exponential, we have to keep the base the same. So we'll still have this equation. The base of the logarithm is 2, and the base of the exponential is also going to be 2. Remember that exponentials and logarithms are inverses of each other, so after we keep the base the same, we're going to switch those other two numbers. So 2 to the third power is equal to 8. Now, when we're given numbers like this, it's real easy to check. 2 to the third power is equal to 8, so we are right. And when we have log base 4 of 1 over 256 is equal to negative 4, again, we keep the base the same and switch those other two numbers. So 4 to the negative 4 power is equal to 1 over 256. Again, this is numbers, so we can plug into our calculator and see that we're right. When we start introducing more variables, we're just going to have to kind of trust it, that when we want to rewrite this log in exponential form, we keep the base the same and switch the other two. So 3 to the w is equal to x, or n to the r is equal to k. You'll also be expected to go the other way. So if you're given an exponential equation, you'll be asked to rewrite it as a logarithmic one. So to do that, when I'm given 15 to the third is equal to 3,375, and I want to rewrite that as a log, first thing is keep the base the same. In my exponential equation, the base is 15, so in the log, my base will be 15. Then we're going to switch these other two numbers around. So log base 15 of 3,375 is equal to 3. When we move over to 4 to the 1/2, remember 1/2 power is a square root. So we want to write that as log base 4. Switch the other two numbers. So log base 4 of 2 is 1/2. When we start introducing variables, this is a common equation that you might want to try and solve. 3 to the x power is equal to 10. Very hard to do if you don't have logarithms. If we do have logarithms, we can rewrite this as log base 3 and switch the other two. So log base 3 of 10 is equal to x. Now there would be a way to type this into our calculator and find that value out. When we're given all variables, again, keep the base the same. My base is a, switch the other two numbers. Z is equal to m. So how can we use our number sense to evaluate a logarithm? It's a new function. We don't really feel very comfortable with it. And all we really have is how to convert it into an exponential. That is how I'm going to evaluate these logarithms. So if we have log base 3 of 81, that has to equal some value. Rewriting as an exponential, 3 to that value should equal 81. So what power would I need to get to 81? I know 3 to the first is 3, 3 squared is 9, 3 to the third is 27, and when I get to 3 to the fourth, that's 81. So we can go back to the beginning and say the log base 3 of 81 is what v was, the power, 4. So log base 5 of 125, we're going to get a value, and that value, remember, is going to be the power. 5 to what power is 125? Well, I know 5 squared is 25. 5 to the third is equal to 125. So the value of that log is going to be the power 3. For log base 4 of 16, Remember, the value of the log is the power. 4 to what power is 16? And it's 4 to the second power. Log base 11 of 11. Well, 11 to what power is equal to 11? And that would be 1. 11 to the first power is 11. And I think we could probably expand this idea a little bit more. For instance, log base 9 of 9. Well, 9 to the first power would equal 1. And log base 5 of what number would equal 1? Well, it would have to be 5. Right? Anytime that we got the base of the log to be the same as what we're taking the log of, then we're going to end up with a value of 1. So we could say log base n of n is equal to 1. And log base 39 of 1. Well, remember, 39 to what power is going to equal 1? Well, that power would have to be 0. In fact, no matter what the base is, if I had 10 to a power and I wanted it to equal 1, that power would have to be 0. So we could say things like log base 18 of 1. That would be 0. Or log base 7 of 1 would equal 0. In fact, no matter what base we have, if we're going to take the log of 1, it's always going to equal 0. Since logs are powers, I want to take a look at some other special powers that we always wonder about. For instance, log base 3 of 1/9. Remember, 3 to what power is going to be 1/9? So when we have that fraction where we got 1 in the numerator and our numbers in the denominator, that's what gave us a negative value. So that power is going to be negative, and to turn 3 into a 9, that would be to the second power. So that means when we're taking the log of this fraction, we should have a value of negative 2. And log base 25 of 5. Well, 25 to what power is equal to 5? We know that it's the square root of 25 that's equal to 5. As a power, a square root is going to be a fraction, 1/2. But when the base and what we're taking the log of are both fractions, again, we can think of this as a power. 1/6 to what power is 1 over 36. Since they're both fractions, the power is going to be straightforward. 1 to any power is going to be 1, but 6 squared is going to be that 36. So this log is going to be 2.